A very good morning to one and all. I am Priyanka Sapkal from Goregaon MPS Municipal Secondary School East Bmc Education Department. So students, today we are going to continue with our topic of chemical reactions and equations. So let's start with our topic. Now students, in your previous lecture, we have seen about different types of reactions, that is combination reaction, decomposition reaction. Then we saw about the displacement reaction, in that two subtypes, that is the single displacement reaction and the double displacement reaction. Then after that, redox reaction, in which oxidation and reduction reaction. Now students, now these reactions are happening. Okay, we are talking about the different types of reactions are happening in our day-to-day life, different types. But how these reactions they are happening, that means what are the factors which are affecting the rate of chemical reaction. Okay, so that is also one of the important part to study, because now how will be the nature of the reactants, how will be the size of the particles of the reactants, what will be the concentration of the reactants, then what will be the temperature, what then should we use the catalyst or not, why we are using the catalyst. So these are all different types of factors which affect the rate of chemical reaction. Okay, in some cases the reaction becomes slow, so to increase the rate, what we do, we just make the finely sized particles, that means a small size particle, we react with them, because if we use the small size particles, then what happens, collision occurs to a greater extent because surface area increases. That means there are different factors which affects the rate of reaction. Okay, if you are using the solid state, how will be the rate of reaction? If you are using the liquid state or gaseous state, what will be the rate of reaction? So all these things, they affects its rate. Okay, so there are different factors which affects the rate of chemical reaction. So we will see one by one. So first we will study about the nature of the reactants. So here different factors are given, that is the nature of the reactant, size of the particles of the reactants, concentration of the reactants, temperature of the reaction, and catalyst. So first is the nature of the reactant. Now students, the rate of reaction, it depends on the nature of the participating substances. Okay, so reaction that appear similar may have different rates. Okay, under the same condition, depending on the identity of the reactants. For example, if you have taken compounds, or if you have taken two elements A and B, okay, if you react them, in low temperature they are reacting differently, whereas in high temperature they are reacting differently. That means the reaction is same, but the rates are different. Okay, so under the same condition, depending upon the identity of the reactant. So for example, when small pieces of metal ions and sodium, they are exposed to air. Okay, when very small pieces of metal ions and sodium, when you exposed it or you keep it as it is in the air, okay, in suppose in a petri dish you kept it, then what happened, the sodium reacts comparatively, or it reacts completely with air overnight, whereas the iron is barely affected. Now why this is happening, that means two different types of metals you have kept. Okay, and you exposed it in the air, but the sodium, it reacts fast as compared to the iron. Okay, the reaction is same. Okay, the whatever the environment which is given, that is also same, but the iron is barely affected. So why this is happening, because the active sodium, okay, they react very fast as compared to that of the iron. Okay, so why this is happening, that also we will see. So for example, another example we will see, the active metal calcium and sodium, they both react with water to form the hydrogen gas and a base. Okay, so calcium and sodium, they both, if suppose for example calcium reacts with water and sodium reacts with sodium also reacts with water. Okay, they both give you hydrogen gas and one base it will be given. Okay, so base will be NaOH and hydrogen gas, that is H2 will be released. But yet calcium reacts at a moderate rate. That means calcium reacts slowly, whereas the sodium reacts so rapidly that the reaction is almost explosive. Okay, now why these cases are happening? That means here in this case, in the first example also, between the sodium and the iron, what is happening when they are reacting with the air, that means when they are reacting with the oxygen, sodium reacts there, it reacts there fast as compared to the iron. In the same case, in the another example, calcium, it is reacting little bit slow than that of the sodium. Now, why sodium is reacting so rapidly? It depends upon the nature of the metal. Okay, how much the metal reacts vigorously, or how much, or what is the reactivity of the metal. Okay, if the reactivity is high, then they will definitely react fast. Okay, if the reactivity is low, then they will take a little bit time to react with the another element or a compound. So here you can see sodium metal is there. Now here sodium on the left hand side, this is the solid form of sodium metal, and on the right hand side it is the power, means little bit finely divided, fine particles of the sodium metals. So if you will take the example, the left hand side sodium metal, then that will react little bit, that will also react, because sodium is very highly reactive. Even if you will touch it now, your hand gets burned. Okay, so these metals, these highly reactive metals, sodium, potassium, you cannot handle it by your hands. Okay, then also you have to store it in the kerosene, because it vigorously react with the oxygen in the air. So these are the cases how metals, they are handled very carefully, means that means highly reactive metals. Okay, the metals which are of less reactivity, they can be handled easily, but the highly reactive metal, they are handled with so much care. Okay, so here in this case, with the nature, you can say that on the reaction of all these elements, or whatever the metals are there. Okay, the nature of the metal is responsible for the difference in the reactivity. Okay, so here in this case, then in the nature of the reactant, what we had said, reactant means whatever the reactants we are using on the reactant side. That means here in this case, the metal is responsible for these different kinds of reactions. Sodium is highly reactive, that's why it is reacting faster as compared to the other metals. So here in this case, iron and calcium, these metals, they are not reacting so fast as compared to the sodium, because sodium is highly reactive. Now then, if you take the example of potassium with sodium, then potassium will react high as compared to the sodium, because potassium is more highly reactive than that of the sodium. So here it depends upon the nature of the reactant, the nature of the metal which you are using here, or whatever metal, non-metal, it depends upon their reactivity, how much they are reactive. Depending on that, the reaction, the rate of reaction, it depends. If it is highly reactive, then the reaction will be it will be fast. If it is less reactive, then the reaction will be moderate. Okay, so then comes the size of the particles. Now, how should be the size of the particle? Now, as you know that if the size of the particle will be less, then naturally the reaction will appear faster. Okay, for example, if you take water and in that you added sugar particles or sugar cubes, okay, then it will take little bit time to melt in the water. But on contrast way, if you just added water, and if you added in a powdered form of sugar, then what it will do, it will mix quickly as compared to that of the sugar cubes. Why? Because the size of that particle was very fine, that's why it takes less time to react with the water. So same way happens here, size of the particles also affect the rate of reaction. Okay, so what happens here, as the size of the particle decreases, then its surface area will increase, and more surface area will be there, then that means high collision will be there, and faster will be the rate of the reaction. Okay, so the rate of the reaction is generally slower in liquids when compared to the gases, and it is slower in solids when compared to the liquids. So the size of the reactant also matters a lot. So the smaller the size of the reactant, the faster the reaction. Okay, so here in this case, now as we know that gaseous, whatever the gaseous substances are there, they are finally divided. That means their particles are very, very small. Okay, and they are always in continuous motion. So what will happen, as their sizes are small, so it will react vigorously and it will react fast as compared to that of the liquid. Now in this case, in the liquid the bonds are loosened up and because of which they are also you can say their particles, they are connected with each other, very loosely bonded particles are there, so they can also react it. They can also react fast as compared to that of the solid. But so in solid state, whatever the substances you are using, okay, the solid particles will be having their bonds will be stronger as compared to the liquid and the gaseous state. So here what happens, it will take more time to break that bond. Okay, more energy will be required to break that bond, and because of which the whatever the time required to get the chemical reaction, it will be slower down. Okay, so here, except for substances in the gaseous state or in solution, reactions occur at the boundary or interface, so between the two phases. Okay, so whenever the substance is a solution and a gaseous state, so in that case, the whatever the reactions it is occurring on the interface. Okay, so between the two phases. So hence the rate of reaction between the two phases is depends upon the great extent on the surface contact between them. A finally divided solid has more surface area available for reaction than does one large piece of same substance, as I already told you. If large substance will be there, then it will take more time to react. But if a small particles or finally divided solid will be there, then naturally what will happen? Its surface area will increase. And as its surface area will increase, it will absorb the things more. And as it will absorb, that means collision will be taken faster. And as the collision will be taken faster, in that case, faster will be the rate of reaction. So thus a liquid will react more rapidly with a finally divided solid. Okay, now as I already told you the example of a sugar water. Okay, water, when in the water you add some sugar cubes, it will take time to melt. Whereas if in the water, if you added the powdered form of sugar, then it will mix rapidly. Okay, why this is happening? Because of the size of the particle. Okay, then large piece, for example, we will take another example that large pieces of iron, it reacts slowly with acids. Okay, finally divided iron, it will react more vigorously with the acid. So large pieces of wood smolder, smaller pieces burn rapidly. Okay, when you add large pieces of wood in the fire, it will take time. Okay, but whereas when you add the small pieces of wood, what will happen? It will burn rapidly, and sawdust burns explosively. Sawdust, you know that you might have seen that in the school, whatever the chalk boxes are there, in that sawdust is there. That is the wood dust. Okay, so this sawdust, it explodes, it burns explosively. Okay, that means here in this case, size of the particle is important for the rate of the reaction. Once again, I'm telling you, if the size of the particle will be less, then what will happen? The surface area will be more. And if the surface area will be more, so naturally it will react with another liquid substances rapidly. And in that case, collisions will be also occurred rapidly, and faster will be the rate of reaction. So here, gaseous state is having the higher rate of reaction as compared to the liquid, and liquid is having the higher rate of reaction as compared to the solid. So here, this also affects the rate of chemical reaction. So first one was the nature of the reactant. Whatever the reactant are present, it depends upon the reactivity of the reactant, how much it is reactive. Then comes the size of the particle. So size of the particles means finally divided particle will react more vigorously and more faster as compared to the big solid particle or large piece of the same substances. Okay. Then now difference in the inherent structure of the reactant can lead to the difference in the reaction. Okay, so molecules which are joined by the stronger bonds will have lower reaction rates than with the molecule joined by weaker bonds. So due to the increased amount of energy required to break the stronger bonds. Now students, as I already told you that for example, the solids are there. Okay, now solids, they are having the stronger bonds. Okay, so as compared to that of the gaseous state. Now, if you will compare the bonds between the gaseous state and the solid state, Okay, the solid substance will be having the stronger bond than as compared to the gaseous state substances. Then what will happen? If you react that solid substance, you require more energy to break that bond. Okay, so if more energy will be required, that means the reaction will take time. To break that bond, you will require energy and time as well. So the reaction will also take time. Okay, it will break, but it will take more time as that compared to that of the gaseous substance. But whereas in the gaseous state substances, now the whatever the atoms molecules are there, they are free because the bonds between them, they are either weaker or no bonds are there because they are always moving here and there. Okay, so here in this case, what happens? The reaction will take fast. Same way for the liquid also. In the liquid state, the bonds are weaker. So it will take less time as compared to the solid because as the bonds are weaker. So bonds also makes an important point to affect the rate of chemical reaction. Stronger will be the bond. So in that case, higher will be the reaction rate. Okay, so molecules joined by stronger bonds will have lower reaction rate than will the molecule joined by the weaker bonds here. That means here in this case, now the stronger will be the bond. It will now it will require more energy to break it, and the rate of reaction will be lower there. Whereas in the case of the weaker bonds, as the bond is weak, so it will require less energy to break it, and hence the reaction rates will be faster. Okay, so here in this case, you can say that there will be increase in the amount of energy which is required to break a stronger bond. So the reaction rate will be lower in it, whereas in weaker bonds, the reaction will be faster as compared to the rate which is present for the stronger bonds. So here, stronger will be the bond, lower will be the reaction rate, and weaker will be the bond, strong. There will be higher will be the reaction rate. Then by decreasing the particle size of a reactant, we are increasing its surface area. Okay, as I already told you. So the greater the surface area will be there, higher will be the chances of the collision, and thus faster will be the rate of reaction. So the smaller the particle size, the faster will be the reaction. Now here in this case, this point tells us that if, for example, one substance, okay, one substance is present, and you keep it as a wholly in one place, okay, and the same substance, if you make a final small size particle of it, okay, and you react these both substance with some another solution or another liquid, then what happens there? Now, in that case, what happens? By decreasing the particle size of the reactant, the surface area increases. That means the substance having the small size particles, in that case, the reaction will be faster because as the size is small, the surface area is increasing. And as the surface area is increasing, so there in that case, there is a higher chance of collision. Okay. So it will absorb the substance also and react fast. So in that case, faster will be the rate of reaction. So here, smaller the size of the particle, faster will be the reaction, and bigger the size of the particle, slower the rate of reaction. So this is the key point of size of the particles of the reactants. Then comes when the concentration of the reactants are raised. Okay, then the concentration of the reactant, it is raised, the reaction proceeds more quickly. Okay, whenever the concentration of the reactant, it is raised, that means here in this case, higher will be the concentration, as we can say, the reaction will be quicker as compared to the reactant having the less concentration. So this is due to the increasing number of molecules that have the minimum required energy. So for gases, increasing pressure has the same effect as increasing concentration. Okay, so here in this case, in short, you can say that now here in this case, whenever we are talking about the increasing concentration, now increasing concentration means what? We are increasing the number of molecules. Okay, whatever the molecules which are required to react, that molecules we are increasing. And as that number of molecules we are increasing, so naturally that molecules will be easily available to react with the another molecules of the reactant. So what will happen? As the concentration of those molecules are increased, so it will react with the another molecules, and hence the reaction, it will proceed more quickly. Okay, the reaction will be faster if the concentration will be more. So here, higher the molecule, it requires less energy to proceed with the reaction. So hence, for the gases, increasing pressure has the same effect as increasing concentration. So now, whatever we are talking about the concentration for the solids and the liquids, same way for the gases, how we have to increase the concentration of molecules in the gaseous state. Now for the gases, increasing pressure has the same effect as that of the increasing concentration. Then comes when the solids and liquid it reacts, increasing the surface area of the solid will increase the reaction rate. A decrease in particle size causes an increase in the solid's total surface area. Now here students, what it is saying that whenever the solids and the liquid they react, okay, what happens there? Increasing the surface area of the solid. That means if the small size solid particles we are taking, then it will increase the reaction rate. But whereas a decrease in the particle size, what if we are decreasing the size of the particles, it causes the increase in the solid's total surface area. So here in this case, the same way as we talked about that, if the size of the particle is less, the surface area will be more, and higher will be the collision, and faster will be the rate of reaction. So here, in this case, we can say that smaller will be the size, higher will be the rate of reaction, and higher will be the surface area, higher will be the collision, higher will be the absorption rate, and higher will be the reactant. They will react with each other. Then comes the concentration of the reactants. Now in the size of the particles, now this depends upon the size, whatever size we are using for whatever the sizes are there for the both the solid, liquid and gaseous state. Now for the solid state size, that means it should be finally divided. But for the liquid, whenever we are talking about the size, in that case we are considering the concentration of that particular liquid. Okay, then in the we are talking, if we are talking about the gaseous state, then increasing pressure has the same effect as that increasing the concentration. Then comes the concentration of the reactants. Now the rate of many reactions depends upon the concentration of the reactants. The rates usually increase when the concentration of one or more of the reactant increase. Okay, now here in this case, as we know that rates of many reactions, okay, it depends upon the concentration of the reactant. That means how much amount of concentration is there in that of that particular reactant in that particular solution. If the concentration will be more, then naturally it will more molecules will be there to react with the another reactant. But if the concentration will be less, then what we are saying that the number of molecules which are required to react, it will also be less. Then hence in that case the reaction will become slow. So the rate usually increases when the concentration of one or more reactant it increases. So now these statements tells us that as the concentration of one or more of the reactant it increase, the rate will definitely, it will again increase. So rate will be faster as compared to the solution containing less concentration. So for example, calcium carbonate is there. It deteriorates as a result of its reaction with the pollutant sulfur dioxide. Okay, so the rate of this reaction, it depends upon the amount of sulfur dioxide in the air. Okay, how much is the amount of sulfur dioxide? Okay, so if there will be more sulfur dioxide in there, then in that case calcium carbonate it will deteriorate fast. Okay, if the amount or if the concentration of sulfur dioxide in the air will be less, then the rate of deterioration of calcium carbonate will be less. So this means that it depends upon the concentration, or it depends upon the amount of molecule which is present in the reactant. It depends upon its concentration. Higher will be the concentration, higher will be the rate of reaction. Less will be the concentration, less will be the reaction. So here we can say that sulfur dioxide in air, it deteriorates the calcium carbonate. So if the concentration of sulfur dioxide, it will increase, then naturally the rate of deterioration will also increase. Okay. So an acidic oxide, sulfur dioxide, combines with water vapor in the air to produce sulfurous acid in the following reaction. So here in this case, you can say that now SO2 plus H2O. Okay. So here sulfur dioxide, when it combines with water vapor, now see, SO2 is in gaseous state and H2O is also in gaseous state. Now as the water is in gaseous state, that means it is a water vapor in the air. So what will happen? They will react, and then it will form H2SO3 in aqueous solution and SO2 gas with water as a water vapor. Okay, and then again it will gives H2SO3. Now here in this case, calcium carbonate reacts with sulfurous acid. How? Now here in this case, you can see in the above reaction, sulfur dioxide and water vapor, they combine to form a sulfurous acid. Now when? Now after that, in the second reaction, calcium carbonate, it is reacting with the sulfurous acid. Okay, then we will get CaSO3 plus CO2 and H2. So in this case, the deterioration of calcium carbonate takes place in this manner. This is the reaction, how the calcium carbonate deteriorates when there is a concentration of SO2 in the atmosphere. Okay. Then fourth one is the temperature. Now temperature, while studying the decomposition reaction, you have carried out decomposition of limestone. Then lime water does not turn milky before heating the limestone because of the zero rate of reaction. Okay. So in this case, we had learned that the rate of reaction is increasing on increasing the temperature. So here, chemical reactions typically occur faster at higher temperatures. Okay. So if the temperature will be high, the reaction will be occur faster. For example, now whenever it happens that when your mother cooks food and she kept that food left over on the kitchen counter, means till night, then what happens? If the temperature is higher, this food will get spoiled. Okay, so food can spoil quickly when left on the kitchen counter. However, the lower the temperature inside of the refrigerator slows the process so that the same food remains fresh for days. So here in this case, so what we do, we keep that food. If it is not in use, if we took the required amount of food and the remaining food, we kept it in the refrigerator, what happens? Because of the lower temperature, whatever the process of spoiling of food is there, it slows down. Okay, and as it slows down, so it remains fresh, and so we can use it for next day also. So here in this case, as the temperature lowers, the rate of reaction also decreasing, and as the temperature is increasing, the chemical reaction, it will occur faster. So here this is one of the example of our day-to-day life. Then if we use a burner or a hot pan in the laboratory to increase the speed of a reaction, that proceeds slowly at an ordinary temperatures. So in many cases, an increasing temperature of only 10 degrees centigrade will approximately doubles the rate of reaction in homogeneous system. Homogeneous means similar. Heterogeneous means different system. So here in this case, you can say that as the temperature increases, so as the temperature increases, what will happen? The rate of reaction will also become faster. But as you lower the temperature, the rate of reaction, it decreases. Okay. So why this happens? Because higher the temperature, the chemical reaction, it will occur faster. One of the example of the food which of our day-to-day life which I gave you, that will be easier for you to understand. Okay, so if the food, if you kept outside for more than hours, it will start spoiling. Okay, because of the increasing temperature in the atmosphere. But if you kept that food in the refrigerator, it will slows down the process of food spoiling and it remains fresh for days. So this is one of the example how the temperature is important for or it affects the rate of chemical reaction. Higher the temperature, higher will be the rate of reaction. Less the temperature, lesser will be the rate of reaction. Okay. Then comes the catalyst. Now, students, catalyst means what? Now, catalysts are those substances which increases the rate of reaction by lowering the activation energy needed for the reaction to occur. So the catalyst is not destroyed or changed during the reaction. Okay. So now catalyst is that particular substance which itself will not undergo any change, but it will increase the rate of the reaction. Okay. So that's why we are writing the catalyst over the arrows. Whatever the reactions are there, over that we are writing the name of the catalyst. Okay. Because what it does, it will not undergo any change in itself and neither it will react with the reactant. But what it will do, it will only increase the rate of reaction. And hence for increasing the rate of reaction, we require catalyst. So here in this case, for example, at ordinary conditions, H2 and O2 do not combine. Okay. So however, they do combine in the presence of a small quantity of platinum, which acts as a catalyst, and the reaction then occurs rapidly. Okay. So whenever H2O2 will react, it will not react in the ordinary conditions. So what we do, we add platinum as a catalyst, and because of which it starts reacting and react rapidly also. So here, for example, you can see now there are different types of catalyst. One is the positive catalyst and another is the negative catalyst. Now the catalyst which increases the rate of chemical reaction, it is known as the positive catalyst. Now we are using the catalyst. Okay, but in catalyst also there are two types. One is which increases the rate of reaction and another is which decreases the rate of reaction. So the catalyst which increases the rate of reaction, we called it as a positive catalyst. And the phenomena is known as the positive catalysis. Okay. For example, you can see here twice KClO3, it will give you KCl and O2. Now how it is giving you? Here the breakdown of the substance is taking place. Here the reactant is 1 and product is 2. That means here decomposition reaction is happening in presence of catalyst. Okay. So MnO2 is the catalyst which is written over the arrow. Now always remember the catalysts are never written in the reactant side. It is always written over the arrow. Okay, over whatever the arrow which called it as yield. It is written above the arrow. Okay, because it never react with the reactant and it never makes any change in itself also. Only the thing it does is it just either increase the rate of reaction or it will decrease the rate of reaction. So that's why the catalysts are written over the arrow. Arrow is also known as yield. So we can say that it is written over the yield. Then here the breakdown of the KClO3 is given here. Then comes H2O2. Now in presence of platinum, what happens? It break down into H2O and oxygen. Water and oxygen we are getting. Now here in this case, the reaction it does not happens in ordinary temperature or whatever the ordinary conditions are there. It never happens in that. That's why we are using the positive catalyst so that it will increase the rate of reaction and we will get the desired product. Now in most of the industries and the factories, this catalysts are used because if we want a required and desired product, for in that case and we don't have that much time to wait. Okay, the reaction will occur, but if the process is very slow, then what we do, we add some catalyst so that the reaction will be faster and we will get the desired product in a desired time. Okay, then comes the negative catalysis. Now what do you mean by the negative catalysis? Negative, the word itself tells that here the catalyst which decreases the rate of reaction. So as I already told you, catalyst will never react with the reactant, or it will never go or it will never undergo any change in itself. The only thing is either it will increase the rate of reaction or it will decrease the rate of reaction. So depending upon its increase and decrease rate of reaction, there are two types of catalyst, that is the positive catalyst and the negative catalyst. So as we have shown, positive means it increases the rate of reaction, and negative means it decreases the rate of reaction. So here the catalyst which decreases the rate of reaction, it is known as the negative catalyst, and the phenomenon is known as the negative catalysis. So here acetanilide, which is written over the arrow H2O2, now that is the negative catalyst. Now just understand the difference between the catalyst and catalysis. Okay, negative catalysis is, it is the process or it is the phenomenon. But here negative catalyst means whatever the chemical we are using as a catalyst, so that particular thing is the catalyst. So here acetanilide, which is written over the arrow, that is a catalyst, and as it is decreasing the rate of reaction, that is a negative catalyst. Okay, so here breakdown of H2O2 into water and oxygen. So in this case, we want the process should be slow, or there should be decrease in the rate of reaction. If it is very much faster, then to decrease it, we are using this kind of negative catalyst. Now in the factories and the industries, catalysts are used. Most of the time their catalysts are used, and in the laboratories also, if you want any chemical product, and if you want to increase or decrease the rate of reaction, in that case also we are using the catalyst. Then knocking off petrol by tetraethyl lead. So this is also one of the example of a negative catalyst. So here once again, what do you mean by the catalyst? Catalyst is nothing but the substance in whose presence the rate of chemical reaction changes without causing any chemical change to it. It is known as the catalyst. So just remember this definition. Now here in this case, there are two types of catalyst, positive catalysis and negative catalysis. Now catalysis is the phenomenon, it is the process where increase in rate of reaction happens by adding the positive catalyst. So if it is asked name or give one example of a positive catalyst, you can say MnO2, platinum. These are all the examples of a positive catalyst which increases the rate of reaction. Then if it is asked that give one example of a negative catalyst, then acetanilide is the example which decreases the rate of reaction, and it is the negative catalyst. So likewise, these are the factors which affect the rate of chemical reactions. So once again, in short, we will just recall it. Okay, so here the factors which affects the rate of chemical reactions are, so there are 5 factors which affects the rate of chemical reaction. So now these factors are very much important, because if we want to increase or decrease the rate of reaction, these factors we should know. Okay, so first is the nature of the reactant, then comes the size of the particles, then comes the concentration of the reactants, then temperature of the reaction, and then comes the catalyst. So first is the nature of the reactant. Now what happens here in this nature of the reactant? Here in this case, it depends upon what kind of reactant is present, whether it is highly reactive or whether it is less reactive. If highly reactive reactant is present, reactant means the substances which is present on the reactant side, that is on the left hand side. Then product means the substance which is present on the right hand side. So here reactant are those substances which react to get a specific chemical reaction. So here in this case, if the reactant is highly reactive, then it will react faster. So in that case, we can say that the rate of reaction is higher for that particular reactant. For example, if sodium metal is there and iron filling is there, sodium will react more faster as compared to that of the iron, because the rate of reaction of sodium is high. Same way, if you take the example of sodium and calcium, in that case also sodium will react faster, because the rate of reaction and the rate of reaction of sodium is higher, and because its reactivity is higher than that compared to the calcium. And if you take the example of potassium and sodium, potassium will react faster as compared to sodium. Okay, because the reactivity of potassium is higher as compared to the sodium. So it depends upon the reactivity, how it reacts. Okay, the rate of reaction happens in higher will be the reactivity, higher will be the rate of reaction. Okay. Less will be the reactivity, less will be the rate of reaction. Then this is sodium metal, you can see. Then comes the size of the particle. As I already told you, less will be the size, higher will be the surface area, and higher will be the collision, and faster will be the rate of reaction. This is the important point which you should understand, that the gaseous state substance will react faster as compared to the liquid, and liquid state substance will react faster as compared to the solid. So here in this case, a finally divided solid particle will react faster as compared to the large piece of the same substance. So here in this case, once again, smaller will be the size, higher will be the surface area, and higher will be the surface area, higher will be the collision, and higher will be the collision, then faster will be the rate of reaction. Then if the bond is strong, naturally it will require more energy to break it, and hence it will lower the rate of reaction. But if the bond is weaker, then it will break faster, and hence in that case the rate of reaction will also be faster. Then same case which I already told you about, the if the particle size is less, surface area will be more, collision will be more, and the faster will be the rate of reaction. Same way, if the concentration of the reactant is more, in that case also the faster will be the rate of reaction. And for the gaseous state, concentration means increasing pressure. Okay, increasing pressure has the same effect as that of increasing concentration. So if you increase the pressure of the gaseous state substances, in that case it will also react faster. Okay, then comes concentration of the reactant. Now higher will be the concentration, obviously higher will be the rate of reaction. If the concentration of the substance is more, the higher will be the, because in that case number of molecules will be more to react, and as the number of molecules will be more to react, so naturally the rate of reaction will be faster here. So one of the example is deterioration of calcium carbonate. So it deteriorates if there is a pollutant called sulfur dioxide is present in the air. Pollutant means the substance which makes the, or which creates the pollution. So that is known as the pollutant. So if the concentration of sulfur dioxide will be more, so naturally calcium carbonate will be deteriorate faster. But if the concentration of sulfur dioxide will be less in the atmosphere, so naturally calcium carbonate will not deteriorate faster. It will take a time. It will take time to react. So here higher the concentration of the reactant, then higher will be the rate of reaction. Less will be the concentration, less will be the rate of reaction. Then temperature. Higher will be the temperature. Naturally, the reaction will be higher will be the rate of chemical reaction. Then if the temperature will be low, then naturally the rate of reaction will be also lowered in that case. One of the example I told you of day-to-day life, that is of food. If you kept that food for longer hours on your kitchen counter, then what happens? It starts spoiling faster. But if you kept that particular food in the refrigerator, so in that case, the process of spoiling of food, it decreases. The rate of that particular reaction decreases, and the food remains fresh for days, so you can use it. Okay. So here in this case, the chemical reaction, it typically occurs faster at the higher temperature. Then catalyst. Catalyst is that substance whose presence in whose presence the rate of chemical reaction it changes, so without causing any chemical change to it. So here in this case, it will either increase or decrease the rate of reaction, but it will not combine with the reactant. Two types of catalyst are there, positive and negative. So positive catalyst, it increases the rate of reaction. Negative catalyst, it decreases the rate of reaction. Let's see some questions. What will happen if the reactant is in powdered form? Now, as I already told you, if the reactant is in powdered form, in that case, what happens? If the size will be less, then surface area will be more and higher will be the collision, and faster will be the rate of reaction. Then second question is, what will happen if the reactant is in dilute form? Now, there are two types of solution, concentrated solution and dilute solutions. So in dilute solution, the amount of molecule is less, that's why it is known as dilute. But whereas in concentrated solution, the the amount of molecule is more. So naturally, if the reactant is in dilute form, the number of molecules will be less, and if number of molecules will be less, so naturally the rate of reaction will be also less. It will not be faster. But whereas in contrast, if the concentration of the reactant is more, the rate of reaction will also be more. So what will happen if the temperature of the reaction increases? Now, if the temperature of the reaction increases, so naturally the rate of reaction will also increase. Then what is a catalyst? So as I already told you, the substance in whose presence the rate of chemical reaction changes without causing any chemical change to it. It is known as the catalyst. Okay. So any doubt, student? If you have any doubt, you can ask. Yes, Ansari? Ansari? Just unmute yourself. You are raising your hands. Do you have doubt? Okay, yes, Imran. Unmute yourself and ask. No? Okay, Ansari? Can you hear me? If you are having doubt, then ask the question later. Otherwise, don't raise your hands. Any query, any doubt you have? No? No one? Okay. Okay then, students, thank you very much.
Okay, thank you, ma'am.
Thank you, ma'am.
Yeah.